Hi guys. Today all we're going to do is the multiple. I'm not talking to you. The multiple choice questions on the last page of your packet, and then you guys are going to have like a little wrap up quiz. Okay. So let's go to the multiple choice questions. And I'd like you to push pause and try them first.
Are you talking to yourself?
Yeah.
No, I'm not. I was just asking.
Okay, so I'd like you to try them first, and I just want to warn you that they are really tricky. So I would first think about things like what direction are they shifting, and then if it shifts in a certain direction, what will happen then? Okay, so push pause, try them, and then when you come back, I'll just go over and explain them. Okay, so in number 1, it says which change will not affect equilibrium concentrations? Adding more will make it shift to the right. Adding a catalyst, no shift. Increasing temperature shifts away. So this would be to the left. And increasing pressure shifts to the side with fewer molecules, which is, this is 2, 3, 6, 5, and 1. So this would be a right shift. So the answer is adding a catalyst. Okay, number 2, the reaction will shift to the right if, and I just go through and see what they all do. It's good practice. Temperature increases. So this is heat right here. So if I'm increasing heat, it shifts away from the heat. So it shifts to the right. So obviously that's the answer. Temperature decreases would shift towards the heat, left. Pressure increase, pressure decrease. So 1/2 plus 1/2 is 1 gas on the reactant side, 1 gas on the product side. So both of these are no shift. So that's why 2 is A. Guys, quiet. Okay. In which reaction will the point of equilibrium shift to the right when pressure decreases? Stop. When pressure decreases, it shifts to the side with more molecules of a gas. So since we're shifting to the right, that means there's more molecules on the right. So I'm just going to go through and count. So 1 plus 3 is 4. 4 gases on the left, 2 gases on the right. So this would be a left shift. 1 plus 1, so you have 2 and 2. So this is no shift because the number of molecules are the same. Letter C, you have 0 gases and you have 1 gas. So this is the right shift. This is your answer. But I'm just going to double check letter D. I have 1 plus 1, so I have 2 and 2. So this is no shift because the number of molecules are the same. Yeah, ask Daddy. Okay. So number 4, the addition of a catalyst will increase the rate of the answer is both forward and reverse reaction. So in a, sorry, Allie, potential energy diagram, you have activation energy of the forward reaction, activation energy of the reverse reaction, and then if I add a catalyst, it makes my hill get smaller. So it reduces the forward activation energy and it reduces the reverse activation energy. So that's why it helps out both the forward and reverse reactions. Okay, number 5. Which conditions would yield the most product? So if I'm yielding the most product, that means I'm making more C. So if I'm making more C, that means you are shifting right. Okay, or the reaction is proceeding to the right. Okay, so low temperature will slow things down. So you can also think about it if like you lowered the heat, it would shift left and it would favor the reactants. So it can't be anyone with low temperature. So high temperature causes more collisions, and that's why in an endothermic reaction, it'll shift to the right. Hold on, Mason. And then now let's look at the pressure. So I have 2 + 1, I have 3 moles of gas on the left, and I have 1 mole of gas on the right. So what kind of pressure change would cause the shift to the fewer gas molecules? So fewer gases means less pressure. So a high pressure would cause that to shift to the right. So high pressure shifts to the side with fewer molecules. I'm almost done. Okay, next one. Okay, a saturated solution is represented by the equation AgCl plus heat plus yields Ag plus and Cl minus. A change will cause an increase in the amount, which change will cause an increase in the amount of Cl, AgCl. So if I want that to increase, that means I have shifted left, because remember, whatever direction it shifts in has an increase. So since AgCl is on the left, this means this is a left-hand shift. Okay, so then I'm just going to go through same thing. A decrease in pressure. So these are not labeled, but these are aqueous. So in letter A, there are 0 gases on either side, so it cannot be a decrease in pressure. An increase in temperature. So if I increase heat, I'm increasing on the left, so I shift away. So this would shift to the right. So it's got to be one of these. A decrease in Ag, your reaction feels like not enough Ag has been formed, so it needs to shift in that same direction to make more. So this is a right-hand shift. An increase in Cl, so I'm just going to line that up. An increase in Cl has too much, your reaction feels like too much Cl. I'm going to shift to get rid of it. Shift to the left. That's your answer. 7, which change will shift the equilibrium to the right? These are easier when they ask about just the straight up shifting in which direction. Okay, so if I, in letter A, if I decrease SO2, the rule for decreasing is shifts towards the decrease. So since it's on the left, you have a left-hand shift. Decreasing pressure. So now I'm going to count up my gases. So I have 2 + 1, so I have 3 gases on the left, 2 gases on the right. So if I decrease pressure, I shift to the side with more gases, which is left. Get down. Get down. You better hurry and get down. Okay. If I increase O2 on the left, I have too much O2, so I shift away from what was increased. The right. Okay, so that's obviously going to be your answer. If I increase the temperature, so it's like I'm increasing heat, since heat is on the right, it needs to shift away from the added heat. This would be a left shift. Okay, and I think there may be one more slide or maybe 2. Okay. All right, and then the last little bit. Okay, number 8, if oxygen is added to the system at constant pressure and temperature, the number of moles of HCl will blank. Okay, so for this one, since I'm increasing oxygen, when you increase on the right-hand side, it shifts away from the increase, which is left. Okay, so that means everything on the left-hand side increases, and then anything remaining on the right will decrease. So HCl will decrease. If the temperature of the system is increased, the rate of the forward reaction will blank. So I think this should be a Cl2 plus 2H2O. So since this is a positive delta H, this is heat. So plus heat yields 4HCl plus O2. Okay, so since I'm increasing the temperature, it is going to favor production of the products. So that is a right-hand shift. That means the forward reaction goes faster. And then the last one, 10, as the pressure increases at constant temperature, the number of moles of HCl will, okay, so I have 1 and 1, so I have 2 gases and 2 gases. So what do we know when the gases are the same? There's no shift. So since there's no shift, nothing is going to change with the amounts. It's going to remain the same. Okay, so that's it. I'm going to post a quiz. I'm not going to help you with the questions, like if you sign on to Zoom, but if you do need help overall with like a concept, I'm happy to help you with that. But I want you to do the quiz on your own, or, you know, with a friend or whatever. Okay, so I think that is it. And then we'll pick back up with our next unit, which is on acids and bases on, I think I'll give you Tuesday to finish, and then so Wednesday we'll pick up with that. And we have 3 units left, acids and bases. Normally I do electrochem after acids and bases, but I'm gonna flip-flop our last unit, which is a bit easier. So in the probably unlikely scenario that we are back in school, our last unit will be one of the ones that's a bit harder. I think that will be harder to learn by yourself. Anyhow, so really we're nearing the end. So, you know, you should be proud that you're almost done. We're happy. Okay, so I will talk to you soon. Bye.